Hello, dear students. In our previous class, we have completed our discussion on ferrous metals as well as ferrous alloys. Now, we will move on to the next classification of metals, that is non-ferrous metals. Now, as we already know, non-ferrous metals are those which do not contain any iron in them. Basically, these are also engineering materials, and we prefer non-ferrous materials due to various reasons, such as good strength to weight ratio, good resistance to corrosion. Now, this good resistance to corrosion is a highlight of non-ferrous metals because always, whenever we talk about ferrous metals, the first thing that comes to our mind is corrosion. That is, oxides are formed, and these oxides we call in our colloquial regular language as rusting. So, non-ferrous metals are generally not subjected to rusting or corrosion. Then these non-ferrous metals are light in weight. They have got high electrical and thermal conductivity, then ease of fabrication, and so on. There are innumerable non-ferrous metals, but we will be discussing only a few of them. Uh, the non-ferrous metals include metals like copper, aluminium, zinc, lead, tin, magnesium, nickel, and so on. These can be used in their pure form, or again, alloys of these non-ferrous metals can also be made in order to improve their mechanical characteristics. And we will see a few of them and their advantages and how do they perform. We'll start with looking at the various, you could say, appearance of these non-ferrous metals. Many a times we can identify a metal just by looking at it. Actually, all of them will have a very different microstructure. The microstructure is, when you observe it under a very special type of a microscope, you can see exactly the grains and the grain boundaries and how it appears under a microscope. And based on the microstructure, you can actually specify which material it is. But for a layman and for us, it is just useful that just by looking at a given metal we can say whether it is a ferrous or non-ferrous, and again in non-ferrous, which one is it pure copper or aluminum or brass, bronze, and so on. One of the most important types of non-ferrous metals is aluminium, which is basically in appearance it is silvery white. It is very soft and ductile. That is, you can easily give it the shape whatever you want. However, the softness can also sometimes be a disadvantage. Hence, pure form of aluminum is generally not used. You are going to add some other metal to it in order to improve its these characteristics. So the properties are, it is very light in weight, and you can work on it very easily. For example, there is an alloy called as duralumin, which is an alloy of aluminium, and this alloy is mainly used in aircraft structures. So obviously, aluminium in its pure form, because it is very soft, you can never use it for aircraft making of aircraft structures and so on. So you have to add something to it. So duralumin is one such alloy of aluminium. Then it is non-magnetic and a good reflector of light because it is shiny. It is highly ductile. That is, you can draw it into thin wires. It has got good electrical thermal conductivity, good tensile strength, and so on. So these are the properties of aluminum, and you can see what are the various applications, like in electrical appliances, transformers, generators. It is also used in aviation, that is what I just mentioned, and automobile industry, and household applications. These days we have aluminum windows also, and sometimes the door frames are made up of aluminum, cooking utensils, reflectors, mirrors, and so on. And this was the one which I was mentioning, that is duralumin, which is mainly used in aircrafts. So you can see a pictorial representation of where aluminum is used, and we can also see that we have a aluminum ladder which is very popular these days, and some parts of a bicycle can also be made up of some alloy of aluminum, because we want these bicycles, especially racing bicycles, to be as light as possible. so that they will have lesser inertia and can go at a faster rate. The melting point of aluminum is about 660 degrees centigrade. Now, then we have copper. Copper is the oldest known metal to human beings, and it has got similar properties to that of aluminum. However, the density is more and it is heavier than aluminum. Um we can say that, again, it has got high electrical conductivity, thermal conductivity, very good corrosion resistance, and so on. However, there was a time when copper was uh, used in abundance in electrical connections and wires. However, these days these wires are getting replaced by aluminum wires, mainly because copper has become more expensive. So even though, in applications we say it is used in making electrical wires, cables, and conductors like this, only if there is no other option, then copper is used. Otherwise, aluminum has replaced copper these days. But there are other applications like the tubes. If you remember our discussion on refrigeration and air conditioning, we have the condenser coils and the evaporator coils. These coils or these tubes are generally made up of copper. And copper is also used in order to make very popular alloys like brass and bronze, which we are going to deal with. And they are used in food and brewing plants, chemical plants, used to make doorknobs, sculptures, statues, etc. So here we can see that, the color is again shiny, and that color itself is called as copper color. We generally don't specify it by any particular name. And even though it is shown that, here it is used for electrical wires and all, these days it has drastically reduced, and newer materials are being used. And the melting point of copper is about 1084 degrees centigrade. Now we will see the alloys of copper, and two main alloys of copper are brass and bronze. Okay, so even though we see them in our day-to-day lives, we find it slightly difficult to differentiate between brass and bronze. The only mode or the way in which we can differentiate is by the color and, of course, their usage. They have got very specific usages. The first one is brass, where it is made up of copper and zinc. So it can contain up to 51% to 81% copper, and the remaining part will be zinc. That is, if you use 51% copper, then you will have to use 49% zinc, or if it is 81% copper, then it is 19% zinc. And the properties are, it is a very good bearing material. We use these as bearings or bushes, many a times, which are used to support rotating shafts. So it is used as a good bearing material, and it has got good machinability. It can be cold worked, that is, you need not heat it in order to give it the required shape and size. At normal room temperature, you can work on it. It has got good castability and resistance to corrosion. And the applications are, they are mainly used in pump parts and marine fittings, valves, condenser tubes, ship components, ornaments, electrical fittings, radiator shells, and so on. These are very common, this thing. But most of you, if I need to take a very common example, then it is the horns and the bugle and the trumpet, whatever we use. Okay, so we say that it is going to be used in trumpets as well as bugles. So most of you might have, in fact, blown a bugle also in your school days. So here we can see that it is a very shiny material. In fact, sometimes people get confused with gold also. Brass in its appearance resembles gold. So they can be used for bullet cartridges, that is, in order to make bullets or firearms. And here you can see that it is, they are used for musical instruments. Then sometimes you use uh, screws also. That is, you can make screws made up of brass and so on. And the melting point of brass is 940 degrees centigrade. Now the next type of alloy of copper is bronze. Here we are going to use, that is, the other metal will be tin. So it is an alloy of copper and tin, and it contains about 5 to 10% of tin. which means that it is made up of about 90% to 95% of copper. This also has got very good strength, uh, and in fact more than brass and copper. It has got good bearing properties and good corrosion resistance, easy machinability, good fatigue strength, and so on. Again, similar applications we have, that is, they are used in pump parts, linings, propellers, boiler fittings, bushes, glands, etc. So, you can see that, we talked about different types of turbines, turbine blades, and so on. Here you can see that the turbine blades are generally made up of bronze, mainly because it is a very hard material, and it has got very high resistance to corrosion. So especially in marine applications where the sea water is salty, it is saline, the parts which are used for marine applications need to have this high resistance to corrosion. Similarly, you can use them to make statues, that is bronze statues and medals and all. If you remember, bronze medal, for example, in Olympics or any such games, that is made up of bronze, and the melting point of bronze is about 950 degrees centigrade. Then there are other forms of or other types of, you could say, non-ferrous metals, such as tin, lead, zinc, and so on. uh, they have got very specific applications, but this is going to suffice our requirement. So thank you, and please go through the video and go through all the properties, uh, and make sure that you remember all of them. Thank you very much.